Alrighty, so this question four is a bunch of data they've given you, and this time we're going to have to do a stem and leaf plot. So we've done stem and leaf plots before. The key word here that we've got to pay attention to is that they want an ordered stem and leaf plot. But this one, you guys are all still with me? The difference between this stem and leaf plot and the ones that we've done before is that this one is a back-to-back one, okay? So the stem and leaf plots that we've done before aren't really that useful, but these back-to-back stem and leaf plots are more useful because what we can do here is we can compare males to females in a leaf plot that goes back against one another. So what we'll do is we'll start having a look at this data, and this bit gets tricky because it's not in order and we're going to have to put it in order. So it's going to get a bit clunky while we draw this up. What I might do is I'll start to fill it in for you, and then I might just pause it, and then I'll just quickly smash it out, and then we'll start it up again so the video doesn't get too long. A back-to-back stem and leaf plot looks like this. So instead of it being like the other one, it's got two halves. So what we'll have in cheat notes, because you don't actually write this on the thing, is remember the 10s went in here and the 1s went in here. So this looks the same as our last stem and leaf plot that we drew, this one over here, except what happens is you might also put the 1s in over here, okay? So what we'll do is we'll put males against females in it. It doesn't matter what side they go in, but this side is male, this side is female. Have a look at the ages. Have a look for the youngest person that you can find in that table. I can see 13. Have a look for the oldest person. I can see a 66-year-old. I don't think I can see anyone higher than 60s. So what you're going to need is you're going to need 10s, 20s, 30s, 40s, 50s and 60s. And then what we're going to have to do is start hunting for the 1s. Now, I'm going to start with the females because it'll make it less confusing. But the key to this is to keep this table extremely neat, okay? We talked yesterday about how the number 1 is quite skinny versus most of the other numbers, and you'll find that bunches up. So you've got to keep these in really neat columns, okay? So going through the table, unfortunately what we're going to have to do, starting with the girls, is look for the smallest number. Oh, there is a 12-year-old there. So let's start with that one. Okay, and 12 goes in. Then I can see that there's a 13-year-old, so that one goes in. And then there's another 13-year-old, so that one goes in. Oh, another one. And we're going to just start chipping away at this. And then once I've run out of teenagers, which I think I've done now, we're moving into 20-something-year-olds. So I've got a 22-year-old there. And this is the bit that I was talking about. Keep it really neat. Keep those numbers going in immediately under the ones above them so that when we go to compare this at the end, the leaves are really neat and you'll be able to see trends in the data. I'll pause this video and finish. Right, so once you've got those in the table, it's a case of a quick count. Make sure you haven't missed anything. So I should have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 29 altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We got 29, and as a side note, I'm just going to put down 29 here because it'll be useful for me later when I start looking for medians and stuff, okay? Now we switch over to the boys. Now when you draw on the left-hand side of the table, which is why I didn't do this first, you've got to do it in the mirror image, if that makes sense. So you're working, which seems odd to us because we're used to working left to right, you've got to work right to left, okay? So you're kind of working backwards. So you do the same thing. Go through all of the boys' ages and find the youngest person. I can see a 13-year-old. So 13 is the first one. So let's get that one in. And the 3 goes here. And you've got to try and write backwards, which is a bit abstract. And then the 14-year-old goes there. And we'll keep going. With this, I've made a mistake in here somewhere. okay, and I'm having trouble finding it, and you can see that by doing it this way, if you don't get it right, it's a big time waster. So you guys are, getting off track because I'm trying to find it. If it's you in a test, you're going to be panicking like me, okay? So I know I've got this wrong somewhere because here I've got 30 people, but I've only got 29 participants in survey at the top. So there's a number out of whack there somewhere, and as we work it out, maybe someone can help me find it.
38. I think there's only one of them.
Cool. That'd be really easy because it'd be right on the end. That'd be awesome. Yep, I'm going to run with that. That sounds brilliant. Thank you very much. So let's ditch one of those 8s. Alrighty, so we're in business. Let's have a look. If you lose it like that, you're going to have to try and dig your way back to find it. Unfortunately, it's really going to chew up your time, okay? This is a good thing to do in pencil because the other thing I notice is once I've crossed all the things out, I can just delete them. But if you're doing it in pen and you're crossing them out as you go, you're going to have trouble reading the numbers after that. You're going to need another test paper. Right. Anyway, let's go having a look at this. There's going to be a couple of questions that follow this. So the problem with these questions is if you can't answer the first bit, you're kind of a bit stuffed before you start, okay? So you need to get as many marks as you can. The median for each set of data, remember the median is what? That's the mean. What's the median? That's the middle. If you arrange something from the smallest to biggest, this is not going to be bad because we did an ordered stem and leaf plot. Now, the thing to remember is if you're trying to find the median position, what you do is you take that number that we wrote down here. We had 29 participants, and you go 29 plus 1 divided by 2 will give you 15. So I'm after the 15th score, okay? And now I've got to go hunting for it. And so remember, it's asking for each set of data. So I've got a male median and I've got a female median, and I'm going to have to count for them, okay? So you are literally getting your going up to your data here and you're counting for the 15th one. So you're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you are remembering that the answer is not 4, it is 34, okay? Don't forget that you've got 10 sitting there. So the male age is 34 of central tendency, and we'll do the same on the other side. We're still looking for 15th score, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It is the 32 years old, okay? And what we might do, just because we're getting prepped for a test, is make sure that we put something like this, years old, or write years old if you're really keen. I don't mind if you want to be lazy. One of the few things about maths is if you don't want to write everything, at least you don't have to. Right. It's going to ask you what general conclusion you can draw from the plot, okay? We better go back and we better have a look at what the question was asking us. So way back at the start here, the following data lists the ages of male and female sports winners over a 29-year period. Okay. And obviously we're looking at their ages. Now, if we have a look at this more generally, okay, because you guys might not be asked this exact question, the benefit of a stem and leaf plot, and everyone should be paying attention to this because this is new, is that you can compare two sets of data. Now, it's like, if you want to think about it, two histograms sitting right next to each other, okay? And I can see that there are a lot of people who are in their 30s, for both males and females. But generally, the male athletes tended to be older than the females, okay? You see how there's kind of like a tendency where it's bulked up a bit in the 30s and 40s for the males, whereas with the girls, you know, for sure in their 30s, and then it's kind of like a more even-ish spread across the other sort of ranges of age. Can other people see this, or is it just me?
No. Yeah. I can say it.
And one of the things that you've got to look for here, and one of the things I'm going to keep hammering home the point on is make sure those numbers line up in columns, because this is going to be nearly impossible to see If you got a string of, say, 21s where you go 1, 1, 1, 1, 1, 1, 1, that section of it will compress, okay, and it will hide the data from you. So what general conclusion can we draw? I would be drawing the general conclusion that most athletes are in their 30s. Overall, and that male athletes tend to be older than the girls. And I get that for two reasons, okay? I can see it physically in the table that it's stacked up a bit in the higher numbers for the boys. But also, if you use our central tendency, which was the whole point of doing the median age of the male athletes is a couple of years older than what the females are. Okay, so we've got it in the table in front of us, and we've also got it in our median scores. So you can get that from both of those spots. All right, and then last question, okay? John Smith was 34 when he received the award for Best Male Athlete. Was this unusual? I'll pause. So was it unusual that John Smith at 34 received an award? No, definitely not. A lot of the male athletes were in their 30s and 40s, and the median age was actually 34. So it's really, he is exactly what we would expect in central tendency. The only other thing that this question doesn't ask you about that you may see in, the test for this topic or the end of year exam is it might ask you a little bit about statistical outliers, and you need to be careful here because, look, there's a couple of pretty old athletes here. Two of the males, one of them's 51, one of them's 66. Okay, now 51 maybe not so much so because there are ones that are 49, but 66 is definitely a statistical outlier, okay, and it will skew the data a little bit. So just make sure that you're keeping an eye out for that, okay? But what you're really looking for, if I'm really crude about this, is where, the lumps are, if you like, in this data, okay? So there's a big tendency for that data to sort of skew into the older male athletes and females. So make sure you keep these neat, make sure you can see them like histograms back against one another.